Hi there, my name is Mihai John and I'm a hands-on tools engineer just like you. I don't like to play the teacher role because I know that word which says if you don't know how to do it, teach others. Today I want to talk about air handling units, the relative humidity, absolute humidity, the temperature. How can we control all these factors to get the best out of our air handling unit? So let's start with the air supply fans chamber. You have to know how it is set up, what parts are used, what sensor is collecting data, and so on. The red arrow is pointing towards variable speed drivers. They can be either Siemens, ABB, dampers. So they are controlled by the programmable logic control and they are driving the motors which is spinning the fan. What you will see here, it is the fan which provides air to the supply air duct. Probably you know this. For a motor to be able to drive the fan through a belt, the supply fan needs a shaft, and on the shaft we'll put a pulley so the belt can be connected using the pulley to the fan motor. The motors also have a pulley, otherwise we wouldn't be able to connect the belts. So the belts are using the motors and the fan pulley to connect the fan motors to the fan itself. A very important part which usually it is ignored, it is the belt which connects the motors to the fans. So the belts make sure that the motors is turning the fan. The DPS, called differential pressure switch, it is a control item which proves that the fan is running by reading the pressure into the fan chamber. So this is a very important control feature. Sometimes this feature is optional because you'll see we have other sensors that will prove if the fan is working or not. As I said before, this is a velocity sensor. It's using a pitot tube and it reads the airflow quantity. Obviously, this will also prove if the fan is working or not, but this is a secondary thing. The first thing for this probe, it is to control the airflow quantity per time unit. That implies volume, and the volume can be calculated by considering the area of the duct, the velocity of the air, and the K factor. But we will talk about this a little bit later. When we cool the premises, we have to monitor the temperature and the relative humidity. So this S3, it is a probe that have the capability to read and transmit to the PLC or BMS information related to relative humidity and temperature. Just like the supply fan, the recirculating fan is controlled by the same type of variable speed driver or variable frequency driver, which practically are similar things, and as I said before, they can be dampers, ABB, Siemens, they many types, so it is up to you what type of VFD you choose to control your air handling unit motors. They are the motors which are moving the fan through a belt. Now you see we have two motors because we want to have an electrical redundancy for these motors. If one is get an electrical fault, the other one will take over. The problem it is with the mechanical redundancy, because if one bearing will be damaged for one motor, that motor is connected to the other one through the belts you just see on this picture, and then there's a possibility that both motors will stop because if one bearing will put strain on one motor through the belts, the other motor will increase the running amps, and the VFD will cut the power to the motor. The belts and the belts quality, it is very important. They are always different type of belts, more or less reliable. So when choosing the belts, make sure that you use the appropriate belts to make sure that they are long lasting, especially for special industry like pharmaceutical companies, where you cannot turn off the air handling unit for 1 year to do maintenance. This is the recirculating air fan, so that helps the air to circulate, actually act like an extractor and as exhaust fan. So these functions are governed by the dampers, which allow more or less air to be either recirculated or exhausted. Just like for the supply air fan, we have a pulley, and as I told you before, if we want to connect a motor to a fan shaft, we use pulleys, and in this way we can use belts to transmit the energy from the motors to the fan, so we can create the ventilation process. Well, this is almost a repetition, but the recirculating air fan, he's got also a differential pressure switch, which is a kind of proven switch that tells you the fan is running, because when the fan starts to run, the pressure inside the duct will increase, and then you'll have a proof that the air is spinning, the fan is spinning. Just like the supply fan sensor, this is recording the relative humidity and the temperatures, and it will send a signal to the programmable logic control, where it will be stored or trended by the WinCC program. So it is a very important sensor, and always have to be fitted into the duct so we can monitor and trend the value of the temperature and relative humidity. The velocity probes are also very important. They're not only collecting data and send it to the PLC to be stored. These type of probes will send data to the PLC, so the PLC will control the speed motors through the variable speed driver to make sure that the air quantity, it is not too high or too low. Something which technicians mostly ignore, the fresh air intake. It is a very important part of the system, and I will explain to you why. Let's zoom into it. This is the fresh air intake duct. Through this way, the fresh air is sucked inside the air handling unit. What you just see here, it is a damper. This is the fresh air intake damper. This damper allows more or less quantity of fresh air to be sucked inside the air handling unit. Because we do not control the nature, it is compulsory to fit into the fresh air intake area a heat exchanger, which is called the frost heat exchanger. As is the air outside goes below zero, we have to heat it a little bit before to allow that air to come inside the air handling unit. The air which comes from outside can have all sorts of debris. That's why we have to use a filter before we allow the air to come inside and to reach to the cooling coil, which is a fresh air conditioning coil actually. This is the fresh air conditioning cooling coil. This coil has two functions. It can run very cold but up just above the dew point, or it can run below the dew point. So this coil will not only cool the air which is sucked from outside, but also it will remove an important quantity of moisture from the air. So that will help us to lower the absolute humidity if we want to control the humidity into the rooms where we provide air. I told you about the sensors. Their duty it is to send information to the PLC, information related to the temperature and humidity. So the PLC will act against the information received from these sensors to control the air quality that goes into the room which I'm providing air to. Like for the supply and return, the velocity sensor, it just tells you about the volume of the air which passing through that point. This is very important because that probe helps us to monitor and control the quantity of air which comes inside the air handling unit. The damper motors get instructions from the PLC and it's manipulating the damper flaps to allow more or less air to come into the air handling unit. What you will see in these pictures, it is the actuator, the V1. This actuator controls the frost heat exchanger's capacity, allowing more or less of the heating agent to pass through the heat exchanger. That actuator, it is proportional and is controlled by the programmable logic controller. It is not 1 to 0, it is actually 0 to 100%. So it is a proportional which progressive will open or close as per need the valve. DPS, differential pressure switch, can be analog or digital. Usually we use analog because we need to know the value of contamination. Filters get dirty, and the dirty they get, the more difference will be in between in and out of the air that passes through the filter. So that's why we use analog differential pressure switches, because we need to read the pressure values. While the time passes by, the filters get contaminated, so we need to know the level of contamination at any time. Just like for the frost heat exchanger, the fresh air conditioning cooling coil also have its capacity control by an actuator which controls the valve that allow the cooling agent to pass by to the coil. So the coil capacity, it is controlled by the programmable logic controller through this valve, which it is a PID valve. It is not 0 and 1. So this valve progressively open or close as per demand. The probe S4. This probe tells us the quality of the fresh air intake after it passes through the frost heat exchanger, the filter, and the fresh air conditioning cooling coil. It tells us the relative humidity and the temperature. It will send the information to the programmable logic controller, and the programmable logic controller will take action as per program that we download in it. This is the recirculated area, and also it is the exhaust area. So I will zoom into it just a little bit, and I'll explain to you how this area is working. Every time when we bring a quantity of fresh air from outside inside the building through the air handling unit, we have to exhaust a similar quantity of air, otherwise we will inflate the building too much. So these two dampers you will see will control the quantity of air that's supposed to be exhausted or recirculated. This is what this section it is for, and it is a very important section into the AHU. Just like for the fresh air intake, the exhaust area have a damper. This damper is meant to help us to control the amount of air we will exhaust from the building through the air handling unit. This is also a PID motor. It is not 0 and 1, so we have the possibility to open or to close the damper or to keep it open in percentage. We can open the damper from 0 to 100%. In this case, the VS4, the velocity sensor, helps us to see if we have enough pressure into this recirculating air area, because if we do not have enough positive pressure, the air can come inside the building through the exhaust, and that could be a serious problem. Please watch my other videos if you want to learn about this problem with the reverse airflow. The mostly ignored as important and treated with misrespect, it is the fresh and recirculated air mixing chamber. I will zoom into this one and I will explain to you how this part it is working. Despite it is massively ignored by technicians, this is one of the most important part of the AHUs, where a good decision or bad decision can affect the air quality through the building. We learn about velocity probes and sensors that control the humidity and temperature. Now in these pictures you can see the big red arrow just passed by the primary filters, which filters the fresh air intake, and it will meet into the mixing chamber with the recirculated air. They have different temperatures, different humidity load, and if they're not very well controlled, you can have a massive humidity in that area, and that can lead to very unpleasant phenomena. You see, we have a damper which allow the recirculated air to gain access to the mixing chamber. This will be 90% most of the time, especially in the pharmaceutical industries, where we use HEPA filter to filter the air, and we do not want to lose that high quality filtered air, so we will exhaust only 10% of the air and we will recirculate 90%. However, the fresh air that comes inside have to be very well conditioned to avoid the big amount of humidity into the mixing plenum chamber. Now the fresh air, it is mixed with the recirculated air, and both are passing to the secondary filter, and it will pass by the main cooling coil, main heating coil, and the humidifier. And now let's zoom into this to see what happened. The fresh air and recirculated air mixture are passing by first through the secondary filter. Immediately it will meet the main cooling coil. The heating coil is another process area, and finally the air will reach the humidification zone, ending up into the supply fan chamber. Just like the primary filter, the main filter must be monitored. The contamination can lead to high pressure into the system, so we use an analog differential pressure switches to monitor constantly the pressure that is applied to the filter due to the contamination. Every single heat exchanger must be controlled somehow, so we choose actuators to control the heat exchanger's capacity, and I will not talk about this too much now, but I want you to see that we have V3, V4 and V5. These actuators controls the cooling coil, the heating coil and the humidifier, and as I told you before, these actuators are proportional. They work on a PID. They are controlled by the programmable logic controller, and they will allow more or less of cooling or heating agent to pass by. So the PLC will get information from the sensors, and when the air needed to be heated or cooled or humidified, or maybe we need to remove the moisture from the air, the PLC will send instruction to these actuators that will control the valve to allow more or less cooling or heating agent to pass by through the heat exchangers tubes. So in this way we are controlling the heat exchangers cooling or heating capacity. The probe S5, it is a very important item used to control the capacity of cooling or dehumidification. So this one, as you see, collects data of the air quality immediately after the air passes the main cooling coil. After the air passes through the all heat exchangers, it's supposed to be perfect, the right humidity and the right temperature. And the supply fan will send this air directly to the rooms. Now we understood how many parts an AHU needs to be able to control the air velocity, the air volume, the relative humidity, and the temperature. Now we have to move further. Something controls these actuators. Something controls the dampers. Something controls the capacity of the heat exchangers, either cooling or heating, or the humidifier. So what controls these features? This is a programmable logic controls, and that PLC is got downloaded a program written by a programming engineer which got the instruction from a HVAC specialist. Now let's look closer. What you will see, we'll see the HMI. The HMI stands to a human-machine interface. It is the panel an engineer is watching. So this panel translates the PLC to the engineer and the engineer to the PLC. The PLC is the man in a mission. Once the program is downloaded and all the sensors are connected, the PLC will collect data through these sensors and it will take action as per the software that has been installed. So the PLC, it is the brain of the operation. We like it or not, every system must have an isolating switch. As you will see here, it shows by the red arrow. So when the switch it is on, we cannot put a padlock on it, but when it is off, we can apply a lotto in case we have to repair the system. So this switch, it is very important to provide power to the system. The safety stop button, it can be many of them, not only one. On any difficult position where a technician can be injured, where the system can be in danger, someone should be capable to push the safety button. It should interrupt not only the PLC, but actually it should cut all the contactors that have the capability to enable motors, steam valves, and so on. The start and the stop switches, sometimes they can be hardwired and they can be physical. You just can press them from any location. Usually they are on a control board, but now with the new technology, you can enable and disable the function of the AHU by pressing onto this HMI touchscreen. Just like I said, if you look now onto the human machine interface screen, the HMI, you will see there is a start and stop switch. So if you press the touch screen, it will have the same function like the other two switches which I just show you below the programmable logic control. They does actually the same thing. So our installation, it is ready to go. But before we go, we have a look around and we do some a little bit more analysis to see if our project is great. What you will see here, you will see the percentage near the dampers that tells you you can turn the damper on or off from 0 to 100%. Although this black arrows shows you the air circulation through the air handling unit. So if you agree with what you did and after you do a proper verification, you prepare yourself to start the unit for the first time and then to commission it. We're just getting there, one step away of turning the switch on. Now if you look very careful, you will see how the air should behave after it passes every single heat exchanger. So as you can see, when the fresh air comes in, the heating coil tries to heat it up, the filter will filter the air, the cooling conditioning coil will try to cool it and to remove the humidity. In the mixing chamber, the air will meet the recirculating air, and the mixture will pass by the main filter, the main cooling coil, the main heating coil, the humidifier, and then will find its way into the supply air chamber to be pushed into the rooms through the HEPA filters. But I'll speak about this in another video. Now I turned on the unit. First, the unit will start to check the dampers. The damper will send a signal to the PLC, telling the PLC that they are healthy. After the damper evaluation, the PLC will instruct the variable speed drivers to start to spin the motors. The velocity probes will inform the PLC about the airflow status, and if the PLC will decide that the airflow is okay, then it will enable the air control capacity system. If the fresh air intake is too cold, then the programmable logic control will instruct the frost coil to heat the air, so it will enable the actuator. The frost coil actuator will be enabled, but it will open slowly. The frost coil will reach the desired temperature, and then the fresh air will start to gain heat, and it will reach the most appropriate heat to meet the recirculated air into the mixing chamber. We cannot control the weather, so the information of the sensor after the fresh air conditioning coil tell us that the air in a mixing chamber has got a very high relative humidity. So the programmable logic control will get that information and will act accordingly. The PLC got the instruction from the sensor and enables the fresh air conditioning cooling coil, and it will run the coil below the dew point, which means the heat exchanger will be very cold. But the sensor now, it tells us that the relative humidity, it is okay, but the temperature, it is too low. So the information will go back into the programmable logic control, and the logic control will take action accordingly. The PLC will enable the main heating coil to bring the temperature a little bit up for the air, because the supply fan chamber have its own sensors which monitoring the temperature and the relative humidity. After few moments, the air gets to the right humidity and the right temperature into the supplied air fan chamber. Like I said before, we cannot control the weather. Now it is very dry and very hot. It is not likely to happen in UK, but this is just a kind of game so you understand better the air handling unit, how it controls the temperature and relative humidity. So if this is happen, the PLC will instruct the frost coil to turn off, and it will instruct the conditioning cooling coil to start cooling the air, but also it makes sure the coil is not going below the dew point, because the air outside, it is very dry and we do not want to remove more moisture from the air. Under such condition, the primary cooling coil, the conditioner of the fresh air, does not have the capability to cool the air enough. So in a mixing chamber, the fresh air is still warmer than it should. Then the information goes to the PLC, and the PLC instructs the main cooling coil to start to cool the air, yet it makes sure that it keeps that coil above the dew point as well. So the only reason we're doing this is to make sure that we're not removing more moisture from the air, which is already too dry. The program is running well. The instructions from the PLC are spot on, and if you look now to the supply fan chamber, the temperature and the relative humidity, it is just okay. This time the temperature reach highest peak. The air, it is extremely high and dry. So what the PLC does, at the moment we have both coils running as cold as possible, but just above the dew point. Yet this is not enough. So let's see how the PLC will instruct these heat exchangers to run. The program in a PLC understands that outside the air is very dry, but yet it needs to cool it somehow because the air is also very hot. So the PLC is instructing the fresh air conditioner to cool as much as possible, even if it has to go below the dew point. Even if when this is happen, we start to remove more absolute humidity from the air, and then let's see what happened further. The PLC understands already that it must sacrifice the humidity to boost the cooling capacity. But in the same time, the PLC will start slowly the humidification process. It will enable the humidifier. So the humidifier will compensate the humidity lost by the air while the cooling process. So let's see what happened next. The humidifier successfully compensates the humidity which is lost by the cooling process. Now in the supply chamber we can see that we have a good temperature and a good relative humidity. So the operation of the PLC, it is a success. Only if you have time to watch this video. Now I want to shrink the air handling unit and to zoom into the heat exchangers. I will not make it very complicated. I will design 3 heat exchangers, 2 cooling heat exchanger and 1 heating. So I'll try to show you clearly how the humidity process and dehumidification process occurs when cooling and heating the air. Imagine we have 3 heat exchangers in line. I mean, the AHU sometimes have only 3 heat exchangers. If they're well designed, they normally have 5. But let's say this one have only 3 heat exchangers. Let's see how they work. You must ignore that measurement device I put to the right hand side. That's just something to be there. Just kind of reference points. Now, as you see this heat exchanger, the line you see which passes by, it is the air. That's all I want myself to represent the air. The air have 2 ingredients, temperature and humidity. The relative humidity, it is how the moisture behave under a temperature stress. So because someone in this case was interested only on temperature, I ignore in this occasion the relative humidity, and also I ignore the absolute humidity. So you have a straight line. There's not heating, there's not cooling. The coils are dead. This is something that you have to pay attention. As you look here, I cool the first coil above the dew point. What means above the dew point? I didn't cool this coil enough, so the air will leave droplets onto its cold surface. So the air will keep its absolute humidity. If you see the green line, it is a straight line that represents the absolute humidity. However, I'm dropping the temperature. When you drop the temperature, you read a higher relative humidity. But that's why it's relative, because it acts according to the temperature. So at this stage, you see to the bottom of the two heat exchangers which are in the left hand side, you have two black arrows. That means the water. If I will ever drop this heat exchanger below the dew point, they will start to sweat and they will start collecting water from the air, allowing the air to dry. So I hope you understood this part. If I must dry the air, I will drop the temperature of that heat exchanger below the dew point. And then the air which passes by will start to leave droplets of water into that heat exchanger surface. And that will be collected by the drain and eliminated through the drain pipe. If you will see now, you drop the temperature, you also drop the absolute humidity, which is the green line. And although you read the high relative humidity, the high relative humidity represents somehow the air solubility. But let's not talk about that right now. So what do you have to know? If you drop the heat exchanger temperature below the dew point, you will dry the air. The absolute humidity drops. You have less grams of water per cubic meter. I hope you understood this part too. If I have two cooling coils and enough capacity, that's a bless. I can use the first cooling coil to dry the air because I will run that coil below the dew point. So that will help me to control the humidity and the temperature. The secondary cooling coil, I will use that one only as a trimmer. I will only drop the temperature without drying the air more, because I will run this coil above the dew point and I will use it only as a trimmer. Even though the relative humidity will have a higher reading because the temperature it is lower. So I hope you understood this. If I will run the secondary heat exchanger above the dew point, the air will not dry more. So the only moisture removal will happen when the air passes by the first coil. You can see the arrow. It is blue, which means the water fall into the drip tray to be eliminated via the drain. And if you look to the end, because I'm not using the heating coil, the absolute humidity is a straight line. So the secondary coil does not affect at all the absolute humidity. If I am unlucky enough to deal with a very humid air with high level of humidity, then I have to run the secondary heat exchanger below the dew point. I have to increase the dehumidification capability. And as you will see now, both heat exchangers are running below the dew point. So the air which passes by will allow a quantity of moisture to sit on this heat exchanger surface to be collected by the drain and evacuated through the draining pipe. But then something happened. As you will see, look to the red line, the temperature dropped twice, but also the absolute humidity dropped twice. And this is a good news because I can dry the air. But in this case, the temperature might get too low and the relative humidity reads too high, even if the absolute humidity is getting low. Because as I told you before, The relative humidity is smart. It's acting against the heat, just like in an electricity. Amps and volts if you have the power constant. There's kind of Ohm law, but this is just a joke. So you always have to remember that the relative humidity is acting as per temperature, but the absolute humidity is not changing unless you run the coil below the dew point, or you'll use a desiccators or any other way of removing the moisture from the air. The bigger humidity and the necessity of running the heat exchangers below the dew point happen to cool the air more than I should do it. And that's why I have to enable the heat exchanger to bring the temperature back to where it's supposed to be. And once I do this, you'll see the difference, how fast the relative humidity drops. And even if the temperature, it is equal with the temperature, if you look to the left hand side where the temperature comes inside to the first heat exchanger, the relative humidity, it is somewhere in the middle, because I remove so much moisture when they pass by through these two heat exchanger, and I brought it back through the heater to the same level like when it came inside, the relative humidity dropped to the bottom. So this is the way you will remove moisture from the air. I hope you understood this. English is my second language, and this is it. To be capable to achieve a good performance, you have to do a lot of measurements, to use specialized tools, to collect data, to train temperature, to train relative humidity, to observe how the heat exchangers are working, to check how much airflow passes by through these heat exchangers. And this is a very, very important operation. If you trend the information, if you have these specialized tools, it's a great thing, because you will be capable to see how the air handling unit or the air conditioning or the heater act under different circumstances. As an example, outside the humidity can be too high, the temperature can be too high, or if you want to heat a building, the customer might be unhappy, but the boiler or the AHU can be perfect, but his walls, his heat transfer outside can be so high that the system will consume a lot of energy. So it is very important to collect this data and to do some analysis in relation to building capability to conserve the energy. So this is something I'm doing myself all the time, the ventilation, the system capacity. Sometime I'm working in the markets, I'm doing a thermal camera investigation to see how the flow of the air. You can have a laminar flow, you can have a unidirectional flow, you can have a very bad flow which affect area that not supposed to. So it burned my budget a little bit when I bought a FLIR camera, but with that one I could see how the heating is dispersed through these laminar flow grills, and I could identify the hot spots. On the other hand, what can I say? I'm a simple engineer just like you. Don't look at this big alleged complicate. There's nothing complicated in life. I'm doing it for 35 years, and I understand programmable logic controls, data. I'm writing my own programs. I'm a gas engineer as well, and I'm working on gas, commercial and domestic and industrial. And I pull only one conclusion. Some people like to be in the office with the clean hands, and they will never be technicians, and they will never understand what we're getting through. Also, there's bigger corporations which try to give you jobs where they think if they'll give you a mobile phone and a van, you just touch the god. No. If you are on tools and you get your hands dirty, you will understand the technology through all your senses. So I'm checking the heat exchangers, the heat exchanger performances and everything. What can I say, guys? I wish you from my heart the best of the best. I'm not doing this for money, and I'm not teaching you what to do. I'm just sharing with you from my experience, and I wish you do the same things. Maybe I might learn something from you. I don't know what to say, but I wish you a wonderful week, and don't work too hard. Try to work smart. Thank you, and I'll see you on another video. Thank you.